G'day, Mr. Bennett here again. Today we're going to be looking at the chain rule and what I call the function of a function rule over here. Alright, so if you look on your sheet, that's these two here that we'll be looking at. So let's get into it. I'll go down and illustrate a couple of examples. Now, you'll find these questions that we're looking at in exercise 3E2. Alright, so now the thing here, what we're doing with the chain rule, we're going to make life a little bit easier for ourselves. So what we're going to say is, if I imagine everything that's in there and I call that u, then I could be writing y equals u to the power of 4. Okay, good idea? So if I did that, then I could differentiate that. So what I could do is I could go dy du, differentiate that with respect to u, not x, and that would give me 4u to the power of 3. Get the idea? And then what I can do is also, if I know what u is actually equal to 3x plus 2, I can differentiate u with respect to x. Okay, and then that would give me, well, that would just give me 3, wouldn't it? Alright, so, and the chain rule says the following. The chain rule says that dy dx is in fact equal to dy du times by du dx. So it's really like it's got this connector thing that cancels out and leaves me with my dy du. So if this is the case, then what I can say is, in this particular case, then my dy dx is in fact equal to, what's my dy du? Well, that's equal to 4. Now u is in fact 3x plus 2 cubed times by du dx. That's in fact equal to 3x plus 2. Right, so that gives me what I'm looking for over here. Right, looking at the second case over here. Right, now the key thing here is to write these as powers. So I could write that as 4x cubed, take 3x. Instead of writing it as a surd, I could write that to the power of a half. Now I want you to think of that whole thing there being u. So that's like u to the power of a half. So again, so let's say let u be equal to 4x cubed take 3x. Then I can say du dx is equal to, I'm differentiating that with respect to x, that will give me 12x squared take 3. If I have my y equal to u to the power of a half, then I can say that dy du, because we're differentiating it with respect to u, that's going to be equal to a half u to the minus a half. Alright, so therefore, when we start looking at using the chain rule, we could say dy dx is equal to dy du times by du dx. So that's going to be equal to, in this particular case, that's going to be equal to a half of, now our u value is, might as well write that in rather than writing an extra line, 3x squared take 3x to the negative half, and you have to times that by du dx. Du dx is in fact 12x squared take 3. And then we'll do the third example. Alright, again, the same thing here is we need to make sure we write this as a power. So that's going to be 5x squared plus 3x to the power of negative 3. So again, in this particular case, what's inside the bracket becomes equal to our u value. Right, so we'd say in math we go let u be equal to 5x squared plus 3x. So then we have to differentiate that with respect to x, and that becomes equal to 10x plus 3. So each of these sort of calculations is pretty easy. Then we can say that y is equal to u to the power of negative 3. So then we say dy du is equal to negative 3 u to the negative 4. Okay, so if I'm looking at doing this one here, then I can say that dy dx is equal to dy du times by du dx. And substitute those things in there. So that's equal to, now we know our dy du is equal to negative 3 5x squared plus 3x to the power of negative 4 times by our dy du dx. That's going to be 10x plus 3. Now you may want to write this as equal to negative 3 lots of 10x plus 3 all over 5x squared plus 3x to the power of 4. So it's okay to do that. Now that's using a chain rule. Now I actually don't do things using a chain rule generally. I use the function of a function. And the way I think about doing that, so composite function rule, if I'm thinking of, let's go up to, let's come down to the one we're working. So an easy way of thinking of doing this one here, this is my thinking for this. Okay, when I'm doing this function, okay, I want to work out my derivative. I do my dy dx. I'm differentiating out. So what I do is I think of that as being the bracket. I don't do anything with the bracket, I just go 4. And then I don't even think about what's in the bracket, and I go 3. And then what I do is I differentiate what's inside the bracket. So it'll be 3x plus 2, and then I differentiate that, that's going to be 3. Alright, probably easier if I actually just do one afresh. So if, let's make one up very quickly. If I have a function like this, let's say y is equal to 12x cubed, take 3x squared to the power of 7. Well, if I'm wanting to differentiate that using my function of a function rule, what I do is I simply go 7 and then 6, and then what I do is I differentiate what's inside. So that becomes 36x squared take 6x. But I have to write what's inside the bracket. But I'm literally thinking about not doing anything with that inside the bracket. So I'm treating that whole thing in here like a big U. Okay, so I just treat that and I do my first thing. So it's really using the chain rule, but I don't have to write all the steps down if I use my function of a function. Alright, so good luck with those exercises in 3E2. Again, it's about breaking it down to 2 steps. Our first step is dealing with the bracket. The second step is differentiating what's inside the bracket. Alright, so good luck with those.